Okay, so for problem number 3, what we need to do is we need to solve this by graphing. And so to solve by graphing, we're just going to enter in the graph of the function and then try to find the x-intercept. So the equation in the textbook for problem number 3 is 4x squared, so I'm going to say 4x squared minus 8x and then plus 3 is equal to 0. So we're not going to tack on the equals 0, we're just going to plug in this expression. Uh-oh, I noticed I put one too many of those. Okay, so now we're going to graph this. And so what we're really interested in is where this graph crosses the x-axis. So I'm going to zoom in so we can see it a little better. And so these are the solutions. Where this crosses the x-axis is the solution to this equation. So what I want to do is I'm going to go second trace, which will give me the calculator function or calculate function menu, and we're going to choose zeros. And so what we're going to do is we're going to come a little bit to the left of this intersection, hit enter, then a little bit to the right of this intersection, hit enter, and then try to get as close as we can to the intersection. And that says that the first zero is 0.5. Now we're going to repeat this process. So in other words, what they're saying is if I take 0.5 and plug it into this equation, I will get y equals 0. That's what that means. So if I plug in 0.5 for x, it will spit out y equals 0. So now let's do the same thing for the second intercept, which is a 0. So the x-intercept occurs when y equals 0. So I move the cursor about the curve until I get to a little bit to the left of the x-intercept. Now I'm asked to find the right bound, so I'm going to go a little bit to the right. Then I'm going to get as close as I can, and 1.5 is going to be the other x-intercept. Okay, so the graph crosses at 0.5 and 1.5. So those are the solutions to problem number 3.